Hey, today we're going to talk about P.6, the rectangular coordinate system and graphs. We're going to plot points on the Cartesian plane. We'll use the distance formula to calculate the distance between 2 points. And we're going to use the midpoint to find the exact middle between 2 points. And then we're going to use the coordinate plane to model and solve real life problems. In other words, story problems. So what is the Cartesian plane? The Cartesian plane was named after the founder, the French mathematician René Descartes. It's a rectangular system composed of an x-axis, which is horizontal, and a y-axis, which is vertical. By putting the x and the y-axis at right angles, we have actually separated a plane space, a plane being, like the surface of this whiteboard here, the board that you're looking at. If I separated that into 4 equal pieces by a vertical line and a horizontal line. Now this x and this y-axis creates 4 quadrants. It breaks the plane into 4 pieces, and those pieces are labeled quadrant 2, 3, and 4. A lot of students forget which quadrant is what. So here's what I've told people. In all my years, I don't think I've seen anybody write a C different than the way I make a C. So if I was going to write the letter C, and I'm going to actually write it on top of my axis, I would start a C, say in quadrant 1. And if I just wrote the letter C, I would just go around in the counterclockwise direction. And I put that arrow on the C, now it looks like a G. But anyway, you get the idea. So I started in the top right. Well, that's quadrant 1. And moving from quadrant 1 in a counterclockwise direction, you get to quadrant 2, 3, then 4. The horizontal real number line is usually called the x-axis. Now we can call it other things, but by default, we're going to call it the x-axis, and the vertical number line is going to be the y-axis. The point where they cross is called the origin. So that's kind of like your beginning point. Anytime you're graphing a point, you're going to start at the origin. That's your beginning point. The origin location is at 0, 0. Those 2 axes divide the plane into 4 parts. And as I said just a while ago, those parts are called quadrants, quad meaning 4. So we have 4 sections. Each point in the plane corresponds to an ordered pair, x, y. And x comes before y alphabetically. So don't forget that. When you're plotting points, we move in the x direction first and then the y direction. It's called an ordered pair because there are 2 numbers, x and y. So the x-coordinate represents the directed distance from the y-axis. So from your starting point, from your origin, the x value is going to tell you to go either to the right or to the left. Positive numbers go to the right, negative numbers to the left. The y-axis, the y-coordinate, is going to tell you which way to go in the y direction. Of course, that's up and down. So we go some certain distance. So if I was going to put some random point x, y, the first thing I would do is move. In this case, I'm just going to move to the right x units. I don't know how far it is, and that's okay. And from there, I'm going to move up y units. So my point x, y, for this case, for this example, is right there in quadrant 1. So obviously, since I plotted a point in quadrant 1, that x value happens to be positive, and so does that y value. The coordinate system allows you to see relationships between 2 variables. It would be difficult to overestimate the importance of Descartes' introduction of coordinates in the plane. His ideas are in common use in virtually every scientific and business related field. We see graphs everywhere, folks. So let's talk about plotting a few points on the coordinate Cartesian plane. And I'll just plot a couple of these. They're actually all plotted on the graph, but I'm actually going to kind of walk through a couple of them. Starting with the first point. The first point is located at -1, 2. So again, remember the first number is the x value, and the second number is the y value. So what I'm going to do is I'm going to go to the origin, which is the beginning where the x and the y-axis cross, and I'm at 0, 0 right now. Now, according to the point -1, 2, -1 is first. The -1 is the x value. Negative tells me to go to the negative direction. So from my origin, I'm going to go 1 to the left. That's -1. From there, I'm going to go up 2, 1, 2, and plot the point. And that gives me the point -1, 2. To plot the point 3, 4, again, the first number is my x value. The second number is my y value. Starting at the origin, I'm going to move 3 units. X is to the left or to the right. In this case, it's a 3, which is positive, so I move to the right. 1, 2, 3. From there, I move 4 in the y direction. Because the 4 is positive, I'm going to move 4 up. 1, 2, 3, 4. And that right there gives me the point 3, 4. And you can do the same thing with the other 3 points given. They are plotted. So you can practice and look at it and see what they're doing there. The distance formula. The Pythagorean theorem tells us that a squared plus b squared equals c squared. And that's simply the Pythagorean theorem. I can actually back that up and go the other direction. If I wanted to get, say, c by itself, in order to get the c by itself, if I had a squared plus b squared equals c squared, I'm going to solve for c. I'm going to rewrite this and put the c first. C squared equals a squared plus b squared. Well, the opposite of squaring something is called the square root. So to get c by itself, I will take the square root of both sides. By taking the square root of both sides of the equation, the square root of c squared is simply c. And the square root of a squared plus b squared, well, it's going to be the square root of a squared plus b squared. And if you'll notice on a regular right triangle, they've labeled a over on this left side and they've labeled b for the bottom. Well, what does a represent? A represents the distance from this point to the top of the triangle. B represents the distance from this point to this point. So in both situations, A and B are a distance. And how do you calculate distance? Well, if I have a number line to calculate the distance between 2 points, I use subtraction. And because distance is going to be positive, we're going to take the absolute value of that. So 6 minus 3 and 3 minus 6, 1 is 3 and 1 is -3. But if you take the absolute value of those, they're both 3. So here's a picture of a triangle, in a sense, drawn on a coordinate plane. So I don't care what 2 points you choose to plot. I can actually, so here's a point x1, y1. Here's a point x2, y2. And those are the 2 points given. And I want to know how far those 2 points are from each other. I want to know the distance between x1, y1 and x2, y2. Well, with any points that you draw, you could actually imagine a vertical line and a horizontal line. So I have a vertical line that's going to be perpendicular with the x-axis, a horizontal line perpendicular to the y-axis. And if I connect those horizontal and vertical lines to the points given, I have made a right triangle. And this is why the Pythagorean theorem comes into play, because the distance from to y2 is going to be the square root of the distance between the x1 and x2 values and the distance between the y1 and the y2 values. I said those backwards. So if I'm going up and down, that's the distance between y1 and y2, and horizontal would be the distance between x1 and x2. So let's look at an example of that. Here it is, actually written out, development of the distance formula. The distance between the 2 points, so d squared is going to be the difference of the x values squared plus the difference of the y value squared. And just like a while ago, to get when I got c by itself, I take the square root. So if I took the square root of both sides of this first line here, that would give me d equals the square root of the x2 minus x1 squared plus y2 minus y1 squared. And now here's the deal. I really don't have to worry about the absolute value bars, because if I take two numbers and I find the difference between those two numbers, that difference could be positive or negative, doesn't really matter. But if I square that positive or negative number, it's going to end up being positive anyway. And that's why you'll see that the distance formula, which is written out again right here, the distance formula doesn't actually have absolute value signs because it's really not necessary. So that is the equation to calculate the distance between 2 points. Here's an example of this. I want to calculate the distance between -2, 1 and 3, 4. Well, start off, and guys, it's a good practice when you're solving problems, especially when you're new to learning equations and formulas and stuff. It's a good idea to go ahead and write down that formula. So in this case, we are going to use the distance formula. So we have x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Now, I've given you 2 points, -2, 1 and 3, 4. Question is, where's the x1, y1 and x2, y2 come from? And the answer is, it doesn't really matter which one you choose to be point 1 and point 2. But just to go along with the example that's provided here, they have chosen to use the first point given as point 1 and the second point given as point 2. And so because that's what they've chose to do, x1 is -2, y1 is 2, x2 is 3, y2 is 4. So now that I've identified all of my variables in the distance formula, I can just plug them in. So x2 is 3 minus x1 is -2. 3 minus -2, and that's going to be squared. The difference in my y values, y2 is 4 minus y1 is 1, so 4 minus 1. Simplifying that gives me 3 minus -2 would be the same thing as 3 plus 2, so 5 squared. And 4 minus 1, of course, is 3, so 3 squared. So that gives me 5 squared plus 3 squared. Well, 5 squared is 25, plus 3 squared is 9. 25 plus 9 gives me 34. So now I have the square root of 34. And if you just type that in your calculator, what is the square root of 34? It's going to give you some number, 5.83, something, whatever. So the distance between those 2 points is about, because it's been rounded, 5.83 units. And if we wanted to, we could use the Pythagorean theorem and check it. Our d squared was the square root of 34 squared equals 5 squared plus 3 squared. Well, the square root of 34 squared is 34. 5 squared plus 3 squared is 34. So it does check. And that's just using the Pythagorean theorem. The midpoint formula. Sometimes it's very, very important to determine the middle of 2 points. Well, to find the middle of 2 points, I've got x values and y values. The middle is going to be halfway between the x values, comma, halfway between the y values. So the formula to find the midpoint is, so how do you find the middle? How do you find the average, right? The average is going to be the middle of 2 numbers. I don't care if the numbers are positive or negative. So to find the midpoint, if I've got 2 points, x1 and y1, x2 and y2, to find the midpoint, I will find the average of the x's value, comma, the average of the y values. And so to find the average, you add them all up and divide by the number of pieces. Well, obviously, we're talking about the middle of 2 numbers. So we'll add the 2 x values together, divide by 2, add the 2 y values, and divide by 2. So I've got a given line segment. I've got a line segment that goes between the 2 points, -5, -3, and 9, 3, and I want to know what's the midpoint. What point is exactly halfway between -5, -3, and 9, 3? So again, it doesn't matter which point is point 1 or which point is point 2. It looks like this text wants to go, well, they've given me -5, -3 first, so that's going to be my point 1. So we'll call this one point 1, and we'll call this one 0.2. By doing so, just like in the last problem, we have identified our x1, y1 values, as well as our x2, y2 values. So to find the midpoint, I need the middle of the x values, the middle of the y values. My x values are -5 and 9, so I'm going to add those together, then divide by 2. My y values are -3 and 3, and I'll divide that by 2. So right there, all we've done is substituted. Next, we will simplify. Let me go back. They don't show a whole lot between there. So what I have now is -5 and 9. -5 plus 9 would be 4 divided by 2, comma, -3 plus 3, that's 0 divided by 2. And then reduce fractions always. 4 divided by 2 is 2. 0 divided by 2 is 0. So the point that's exactly halfway between -5, -3, and 9, 3 is the point to 0 as identified on this next piece right here. Okay. To graph it, if I was to plot the point -5, -3, and the point 9, 3, and 2, 0, it looks like that's the midpoint. So I'm pretty happy with that answer. A football quarterback throws a pass from the 28-yard line, 40 yards from the sideline. A wide receiver catches the pass on the 5-yard line, 20 yards from the same yard line. How far do you throw the ball? Okay, so I want to know how far is it from where the quarterback threw the ball. So here's where the quarterback's at. He's on the 28-yard line, 40 yards away from the sideline here. And he throws it to the receiver who's on the 5-yard line. He's 20 yards from the same sideline. How far is it between those 2 points? Okay, well, that looks like the distance formula to me. So we're going to use the distance formula to calculate this distance. So the 40, 28, that becomes x1. They chose that to be x2 this time. Switch that. 40 is x2. 28 is y2. 20 is x1. 5 is x2. Write down your distance formula, plug in your numbers. As you plug in your numbers, I have 40 minus 20 squared plus 28 minus 5 squared. 40 minus 20 is 20 squared plus 28 minus 5 is 23 squared. 20 squared is 400. 23 squared is 529. 400 plus 529 is 929. The square root of 929 is about 30. So the quarterback threw the ball from the 28-yard line to the 5-yard line to the receiver, but the ball actually traveled 30 yards because it was at that angle there. And then you can just use a calculator again to calculate that square root of 29. Okay, so I would recommend at this time to go ahead and stop the video, take the time and actually work out the practice problems. And then once you've worked those practice problems out, come back to the video and you can watch because I'm about to work them right now. So number 1, find the coordinate of the point on the x-axis and 4 units to the left of the y-axis. So it says it's on the x-axis. So if I was going to sketch a graph, I'll do this down below here. Number 1, if I was going to sketch a coordinate plane, it would look something like this. So that is my x is horizontal and y is always vertical. It says it's on the x-axis. Because it's on the x-axis tells me I'm not going to go up or down at all. I'm going to stay right on this bad boy. But I'm 4 units to the left of the y-axis. So 1, 2, 3, 4 units. 4 units to the right, right there. So what is the coordinate of that point? Remember, a coordinate is labeled as x comma y. So we have to give the x value first. So the x value first is -4. because we went 4 units to the left. So the x value is -4. And because it's on the x-axis, we did not go up or down. So we went 0 distance in the vertical direction. So problem number 1, the answer is -4, 0. Number 2, determine the quadrant or quadrants in which x, y could be located if x is greater than 0 and y is less than 0. Well, problem number 2. If x is greater than 0, that means that x is positive. If x is positive, x is our horizontal distance, and positive is to the right. So for positive, we're moving to the right. If y is less than 0, that means that y is negative. Well, if y is negative, and y is talking about a vertical displacement, y negative, that means we're moving down. So which quadrant would I be in? Here's my quadrant, my coordinate grid, x, y. If I was going to move to the right, change colors here. If I was going to move to the right, now it doesn't say equals 0. So because it doesn't say equals 0, it means I know for sure once I moved over and then down, that definitely puts me down in this lower right quadrant. So what quadrant am I in? Well, let's count. Draw your C, quadrant 1, 2, quadrant 4. So the answer to number 2 is we are in quadrant number 4. Number 3, find the distance between the points 5, 8 and 0, 20. Number 3. Okay, so I'm going to go ahead and just out of sheer convenience, I'll call the first point, point 1, and the second point, point 2, which makes 5 my x1, 8 is y1, 0 is x2, 20 is y2. So my distance formula is the square root of x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. Plugging my numbers in, I have the square root of, so x sub 2, my x sub 2 is 0 minus x sub 1 is 5 squared plus y sub 2 is 20 minus y sub 1 is 8 squared. That gives me the square root of 0 minus 5 would be -5 squared plus 20 minus 8 would be 12 squared, which means the distance is the square root of -5 times -5 is 25 plus 12 squared is 144, which is the square root of 169. Use your calculator if you need to, but hopefully you realize that the square root of 169 is 13. So the points 5, 8 and 0, 20 are 13 units apart. Number 4, find the midpoint between those same 2 points. Well, the midpoint is going to be the average of the x's, average of the y's. So midpoint equals x1 plus x2 divided by 2, comma, y1 plus y2 divided by 2. Plug them in. Well, 5 and 0, 5 plus 0 over 2, comma, 8 and 20, 8 plus 20 over 2, 5 plus 0 is 5. So I have 5 divided by 2, and that doesn't work. So I'm going to write it as 5 halves. 2.5 is acceptable. Comma, 8 plus 20 is 28. 28 divided by 2 would be 14. All right. And that's the end of that unit. And I'll talk about 1-1 in my next recording. Thanks a lot. If you have any questions or something, please get a hold of me. I'd be more than happy to help you out.